Hi there. Thanks for joining me on Rethink Real Estate. I'm on a mission to make real estate work for everyone. Real estate can help to solve climate change, can house people affordably, can create beautiful streetscapes, unify neighborhoods, and enliven cities. So I'm on a journey to find the most creative thinkers and doers out there. I'm not the only one who wants to rethink real estate. You can learn more about me at evepicker.com, or you can find me at smallchange.co, a real estate crowdfunding platform with impact real estate investment opportunities open for investment right now. And if you want to support this podcast, join me at patreon.com/rethink real estate, where there are special opportunities for my friends and followers. Today I'm talking with Sam Ruben, who is passionate, with a capital P, about sustainability. Sustainability is not just a moral principle for Sam. He believes that as a core value, it can improve the bottom line and increase the brand value of any company. And Sam is living this belief. Today he is Chief Sustainability Officer and co-founder of Mighty Buildings, a company that offers 100% digital prefabrication of its modern ADUs and kits. In the first 3 years of their existence, Mighty Buildings developed a breakthrough material that can be printed into any shape, a series of ADUs with a growing order list, and a house kit of parts. Now deploying a Series B round of funding, their goal is to manufacture thousands of houses through the 3D printing material in thousands of locations globally within the next 10 years, reducing waste and energy and helping to house people quickly, affordably, and beautifully. If you'd like to join me in my quest to rethink real estate, there are 2 simple things you can do. Share this podcast or go to patreon.com/rethink real estate to learn about special opportunities for my friends and followers, and subscribe if you can. Hi, Sam. It's really great to have you on my show.
Yeah, really appreciate the opportunity.
So I think you are thinking real estate to the nth degree with your company, Mighty Buildings, which is really such a great name for a company. So I would love you to tell us what Mighty Buildings is all about.
Yeah, so Mighty Buildings, we're a Oakland-based construction technology company that has a mission to create beautiful, affordable, and sustainable housing using 3D printing and robotics. So what we've done is we've developed a unique material and unique printing process so we're not using cement. We've developed a material, it's called Lightstone. So it's essentially a synthetic stone, but we don't have silica, so we don't have to worry about those health impacts. And what we've done is we've figured out how to print it into curves as well as traditional forms, which allows us to print not only the floors and the walls, but also the roof of homes. And so we're initially delivering accessory dwelling units directly to homeowners, and recently announced our first B2B project, which is going to be a community of 3D printed zero net energy homes in Rancho Mirage.
Oh, wow. So then what problems are you hoping to solve with Mighty Buildings?
Yeah, so even though we're bringing 3D printing and robotics into it, our goal isn't to replace labor. What we're really trying to solve is the fact that we just don't have enough skilled labor to build all the housing we need. And in 2008, most of the skilled contractors left the industry. Those that stayed or came back tended to be older. They're retiring and they're not being replaced. For every 5 skilled GCs that are leaving the industry right now, we're seeing 1 lower skilled worker entering. And a lot of
really?
Yeah, it's pretty fascinating. I was talking to a professor at the University of Denver Burns School of Construction Management. He was saying there's something like 400,000 construction jobs that are open in America right now that no one's taking.
You know, years ago, I was hearing this just about stonemasons, that was a really dying trade, but I didn't realize it had now crept into everything.
Yeah, that's what we're seeing. I mean, it's particularly acute here in California, but we're starting to see it in other places in the country as well. And at the same time as we have this huge housing crisis, I mean, globally, we need billions of houses. I mean, in California alone, we need like 2.5 million just to get on par with the rest of the country in terms of per capita housing, not even to actually close that affordability gap. And at the same time, the construction of buildings accounts for 11% of all GHG global greenhouse gas emissions globally. And the building energy use phase is another 28% of greenhouse gas emissions globally, which means that if we're going to solve this housing crisis and we're building billions of new units, we really have to do so in a way that doesn't exacerbate the climate crisis, which, along with the fact that we need a better way to build in order to get all the units out there in the first place, means we need a better way to build to make sure we do so in a way that doesn't exacerbate that climate crisis and frankly leave us worse off than we would be if we hadn't built all that housing.
Wow. So you've had a background in sustainability, I see. So,
Indeed.
yeah, how did you arrive at like this sustainable building solution as something that you wanted to pursue?
Yeah, so it's been a fascinating journey. Sustainability is something that's just kind of always been a part of my life. I was really lucky where I grew up in Ann Arbor, Michigan. We had curbside recycling as basically going. I don't remember not having curbside recycling. So it's kind of one of those things that just was always a part of my day to day. My mom would always compost, and we were always very very eco-friendly in my house. And then obviously the social aspect of sustainability was very important as well, because social justice was something that was very important in my family, and really kind of the ideas of equity and diversity and inclusion were just kind of baked into how I was raised. And so after college, I studied political science and economics in college, thought I was going to be a lawyer. Ended up working in interfaith peace building for a number of years once I moved out to California here in San Francisco. And then attended Presidio graduate school because one day I realized maybe I didn't actually want to be a lawyer, and knew about Presidio graduate school, which is this amazing program that offers both an MBA, so Master's of Business Administration, as well as an MPA, a Master's of Public Administration. And it's one of the first programs in the world to focus the entire curriculum around sustainability and systems thinking. And so was lucky enough to get to go there, decided to pursue the dual degree, so get both the MBA and the MPA. Because coming from the civil society sector, it was really clear to me that too often public, private, and civil society are trying to solve the same problems, but they end up fighting over the resources in doing so because they don't understand each other and they don't necessarily realize that they're trying to solve the same problems. And so that was one of the reasons that I decided to do the dual degree, and then found myself doing sustainability coaching. And in terms of 3D printing, and this is kind of where it becomes obvious just how big a nerd I am. I've been in love with 3D printing ever since I realized that Star Trek replicators were just atomic level 3D printing with energy modulation. So this is where so 3D printing is something I've been passionate about. I've always loved the idea and loved the potential of it. And so in grad school for my MBA capstone, me and my team developed a business model to take clean, virgin, uncontaminated plastic hospital waste and turn it into 3D printer filament.
Interesting.
And so it was an area we've been working in. And then, after grad school, I ended up doing sustainability coaching and consulting, helping organizations optimize their impacts as well as their bottom line, largely looking at building systems. So looking at the envelope, heating and cooling, lighting, but even little things like what's it mean to move a garbage can 10 feet? What's the impact on the waste generated there? And then modeling out both these sustainability impacts in terms of impacts on waste, water, energy, transportation, but then also what are the bottom line impacts? What are the operational efficiency improvements available? And really to put the people I was working with in position to make the business case to their C-suites or their organizational leadership to implement the sustainability changes. And then connected with my co-founders who had originally met each other in Singapore, where the government owns all the housing, and they completely rebuild their housing stock every 20 to 30 years with the latest and greatest in technology. And then they were coming here and seeing it's why are you still building using technology that's 100 or 200 years old? It just didn't make sense to them. And so they had previously come up with a 3D printing concept that was kind of the basis for the technology we use today. And they shared the vision with me, and it just made sense. It really clicked, the fact that we need a better way to build, both to close the housing gap, but also to address the sustainability impacts of that housing was really, really clear to me, and something that I felt passionate about and made it easy to say yes and join the team.
It's really fascinating to me how, all these interests and people sort of collide to make the perfect storm, really. That's pretty interesting.
Yeah, no, and I was lucky because they had worked with a classmate of mine who had been working at Indiegogo when they were doing some crowdfunding previously. And so that's how we connected, is they'd reach out to her. She posted something on one of our Facebook alumni groups. And I think I might have even recommended a former classmate who would advise my capstone team, but he was at the time he had already taken a job with a Hitachi Smart City program. So ended up meeting with our CEO Slava, and just we hit it off, fell in love with the idea, and the rest to say is history. I mean, and that was just about 4 years ago. That'll be 4 years ago in a couple months.
Yeah, it sounds like you're a pretty young company. But what types of buildings are you printing? Like, how far have you come with this?
Yeah. So initially, what we're delivering are accessory dwelling units. So more commonly known as like granny in-law units or granny flats, or just kind of the idea of a small backyard apartment. And the reason we chose that as our initial market is that the state of California has passed a series of legislation going back to 2016. So it went into effect beginning of 2017.
Very familiar, yeah.
Yeah, so that's probably, And so as you know, so made it much easier to permit them, but it also, because of the size of ADUs, they're too small for most builders and developers to really be able to afford to build because of the overhead. And so it not only made a great place for us to step into a new growing market, giving us a chance to demonstrate the viability of our technology while we continue to build out our certification and roadmap, but also meant that we weren't competing with the builders and developers who we've always seen as our customers. Because at the end of the day, our goal is to be a tool for industry and essentially provide production as a service, as a platform. And so to that end, that's why we're really excited about this project down in Rancho Mirage, the Polari Villas that we're doing with the Polari Group, because that's our first foray into that model of delivering units at scale, because that's really where we start to see impact. And so with those, we're doing single family homes plus ADUs. And then we have a new fiber reinforced version of our material that we're working on taking into certification this year, with the hope of being able to move into a low-rise multi-story, hopefully by the end of next year. So
it's not just buildings. It's not just buildings. It's a material that you've developed.
Correct.
Absolutely critical to.
Exactly. Yeah, and it's a non-cement material, and we use light to cure it. So what that means is that it cures quickly enough that it can support its own weight, which is what opens up the ability to bring organic forms and shapes into the printing process, to be able to print the roof as well as the floors and the walls, but not so quickly that we don't get full cohesion between the layers. So that means at the end of the day, we end up with a monolithic object. And so the material itself, I'm sure many of your listeners are familiar with Corian by DuPont. Which has been used as countertops and claddings and things since the 60s. So it's the same class of materials insofar as it's a thermoset composite. But our material is unique in that we've developed a manufacturing process that allows us to put it into a printable form. And we've also designed it and engineered it to be higher performance. So like, for example, Corian, I think generally has a Class B flame spread rating. Ours has a Class A flame spread rating. And then we've also developed the ability to move it into structural aspects of the build as well.
Interesting. So what do your buildings look like? How different are they to stick-built buildings?
Yeah, so we intentionally decided to not go really crazy with the design in terms of highlighting the 3D printing. So the units we're delivering currently are more or less looks like modern boxes, but they have a curved end, which kind of hints at the possibilities. And then, so those are what we call our mighty mods. So our studio 1 and 2 bedroom accessory dwelling units that we're currently delivering. And then our next product line, which is based off of our Mighty Kit system, which is essentially a Sears kit home, but made with 3D printed components. The first unit.
That's one I want to get.
Yeah, and that's what the Polari project is. And so the first product line that we developed with that is called the Mighty House line, and those were designed with EYRC Architects, which is one of the nation's leading modern design firms. So those have a real modern feel to them. Part of why Coachella Valley was a perfect location for the first deployment at scale, because it's the heart of modernism. And so it was really, really great to have a chance to have one of our first big projects right there.
So I have to talk about building codes then, because that must be pretty horrendous trying to convince your local building department that a little building like this, using this technology, complies with all regulations.
Yeah, no, great question. And obviously, because we're bringing something unique into the space, it's been really, really important to us from the beginning that we are addressing the regulatory and safety side of things. Because I mean, as you're well aware, I mean, building codes are written in blood. They exist because things went wrong and people died. And that's the sad truth about it. And so that's why we have so much respect for them. And that's also part of why we stayed in stealth mode for the first 3 years of our existence and didn't really start to talk about what we were doing until last August, was that we wanted to take the time to really be working on the regulatory side. And so we've been partnering with UL Underwriters Laboratories. And the reason we chose UL as our evaluation and certification partner instead of the International Code Council or IAPMO or Aerotech or some of these other evaluation services that are out there is that UL not only has over 100 years of building life safety experience, they also have some of the world's leading additive manufacturing experts, which means that they're uniquely situated to really understand our technology in order to see what does it look like to demonstrate code compliance. And so what's come out of that process is a new standard, which is the world's first standard for 3D printed construction, UL 3401. That's also, and even greater.
What is it, UL 3401?
Correct, yeah, UL 3401. I believe the full title is Outline of Investigation for 3D Printed Construction. And what's really, really exciting is that that has since been used as the basis for Appendix AW in the 2021 International Residential Code update that'll go into effect next year. So that means we've actually helped get 3D printing into the building code in actually pretty much less than 3 years. And so with the new update, once that's published, jurisdictions will be able to take that appendix and plug it into their code because it is an adoptable appendix. And even those that don't formally adopt it will have that opportunity to look to it for guidance as we start seeing more and more 3D printed homes coming to the market.
So does that mean that the tiny little town where I have a little cottage that I like to stay at from time to time that has very, very old-fashioned conservative building codes, that I might actually be able to buy a piece of land and put one of your 3D printed buildings in there next year sometime?
Yeah, well, and potentially you could even do it now, because one of the cool things is that in the meantime, we're able to operate under the alternative means and methods portion of the code, which allows you to build pretty much anything in any way, as long as a building official approves it. And so as long as you're able to demonstrate and provide all the information necessary for them to feel confident that it will have the safety and compliance. And so in that, so what we've been doing there is actually working with the state of California through the Housing and Community Development's Factory Built Housing Program, which allows us to certify our units and effectively get our building permit from the state. So we work with a third-party design approval agency that's certified by the state, and they do all the code reviews. So for all of our units, so that means we get to work with a single design approval agency instead of having to convince each local AHJ. And then we have in-factory inspections by another third-party that's certified by the state as a quality assurance agency. And so that basically takes care of the inspections that would normally happen on site, but can't because we're building in a factory. So that means when we get to the local municipality, it's really about getting the permits for the site work, foundation, utilities, all that, as well as going through the plan check for zoning purposes.
Interesting. So are you the kit of parts that you've developed, are you planning to ship that nationally?
So yeah, so for what we're actually planning on doing is having a distributed network of factories, because for a lot of reasons. One, it does not make sense to ship California construction costs out of the state. Because we have one of the highest cost structures of anywhere in the world. Additionally, we want to make sure that we're not only providing housing for market, but we want to be creating jobs for that market. And so we're identifying areas where we have high demand, where we have builders and developers who we can partner with, and then deploying our factories in existing warehouse space near where the demand is. So that's one of the really cool things about using 3D printing and robotics is out of 50,000 square feet, we can currently produce 300 units a year, or about 360,000 square feet out of that 50,000 square feet of production. And where we're going is to be able to generate 1,000 units or 1.2 million square feet out of that same 50,000 square feet.
Wow.
And so we have the ability to set up in idle warehouse space, like where we are here in Oakland. It's an old Pete's Coffee warehouse. And so rather than needing to build hundreds of thousands or a million square feet facilities that are far away from where your labor and demand centers are. And so that not only reduces logistic costs, but also reduces the carbon cost of that transportation.
That's really interesting. So are you printing building parts as well, or is it complete buildings?
Yeah, so we have the ability to do fully printed shelves. And if people go to our YouTube channel, they'll see one of our studios that we have fully printed. But most of the ones we're delivering currently are actually a hybrid. So they have a 3D printed curved wall combined with a traditional steel frame box. And the reason for that is that, as we've noted, the building industry is understandably, and the building officials are understandably conservative because of the nature of the code being written in blood. And so for us, we've been moving incrementally to make it as easy as possible to get that code approval at every step of the way, while we continue to expand out the certification and testing portfolio, which takes time because many of these tests have backlogs as long as 6 months or more. And so What we've also done is that, and those ones we're currently delivering as volumetric modules. So those are completed, fully finished modules with all the finishing, including appliances and everything, when those arrive on site. And so laid on the foundation and placed in a matter of a day. Then generally, depending on how as we're able to coordinate the subs for the finishing work, ends up being about a week or so until they're completely installed. And so, so we can go from a blank slate to a fully finished in under a month with our mods. With the kit, it's going to be a little more involved on site because it is arriving in shipping containers as panels and as components. But again, with everything you need to fully finish the unit. And so with that, it'll take a few weeks to stand up, but it'll still be faster than traditional on-site construction and less disruptive.
Wow. Okay. So what does the process look like for printing, let's say an ADU from design to move in?
Yeah, so currently we're offering a kind of a set number of designs that we have. So again, obviously taking advantage of prefabrication, in which having some limited customization is going to make the most sense.
It's like the old-fashioned Sears blueprints, right?
For where we are now, yes. Where we're going, as a part of our kit system, we've already developed a Revit library for our panels to make it easy for us to create custom floor plans for builders and developers. Because obviously with volume, it's much easier to do customization. But where we're going is to continue to build that out to allow third-party designers to work directly with our technology. And so be able to bring in those third-party designs and really unlock customization at the scale of a single unit and at small batches. Because for us, we don't need to change the floor or rearrange our production system when we go from one design to another. It's literally just a matter of changing the file in the computer. Wow. So that's one of the really exciting things. And so particularly when we get to multi-story, we're really excited about the opportunities that creates for instituting late stage design changes, because those always come up, but to do so in a way with minimal additional marginal cost.
So what's the end goal date for getting rid of the hybrid and going, fully 3D on these buildings?
Yeah, so we're looking to potentially by next year with our new fiber reinforced material, which the goal is to allow that to remove the structural steel that we're currently using as that kind of safety buffer. Because in truth, our units are currently designed to not need the steel, but we utilize it again just to make sure that have that safety buffer, because it is still new technology. And even though all the testing shows there shouldn't be any issues, we don't want to take any chances.
Sure. So where are you printing now? You said you had 50,000 square feet.
Yeah, so so the whole facility here in Oakland is about 79,000 square feet. Of that, 50,000 is production floor. And the rest is our offices and material storage.
You came out of stealth mode last year. How many people on your team?
Yeah, so we have a pretty large team, and we just closed our Series B. So we're in the process of expanding our team, but we've got about 30 people here in Oakland. And then we've actually got about over 100 people at our research and development facility in Moscow. So that's kind of been one of the secrets to how fast we've been able to move and how fast we've been able to develop this technology, is that we have overseas research. It was originally in Siberia in a city called Tomsk, which is kind of like the Boston of Russia, because it's got similar number of students per capita to Boston and 3 of the top 10 universities in the country. And the reason we have that is that all 3 of my co-founders are originally from Russia, though they all connected in Singapore, and then I connected with them here. And we are headquartered here in Oakland. We are a US company. This is our target market, but having that research and development there allows us to have a much larger team doing some amazing work than we could if we had that R&D based here in the US, particularly here in the Bay Area.
Yes, that's a pretty interesting model and example of partnership between Russia and the US.
Yeah, well, I mean, it really speaks to the fact that there are good people with good ideas everywhere.
That is true, yeah.
And I mean, obviously we're always paying attention to what's happening at the global level between the governments, but that's something you do anyway when you're looking at supply chain concerns. So it's one of those things that obviously we're paying attention to see how it might potentially impact us, but thus far we really haven't seen any impacts. And the biggest have been just visas. So it's been probably the biggest impact in some of the difficulties there, but no real issues in that regard.
So you got a Series B round. What are your plans for scale?
Yeah, so
what's your big hairy goal, audacious goal?
Well, our audacious goal is to hopefully within 10 years to have mighty factories sprout across the globe, starting here in the US and then moving into other countries. We already have interest from the Middle East, Europe, Southeast Asia. And so having these across the globe each generating 1,000 or more units every year. So across mighty buildings, helping support some of the biggest builders in the world to build more with their existing labor, but to do so in a way that provides zero net energy homes, so minimizing the carbon impacts of the energy use phase, but it also zero waste construction. So really eliminating that 3 to 5 pounds per square foot that goes to landfill and traditional build. And we've also committed to being carbon neutral by 2028, 22 years ahead of the broader industry, with a secondary goal of achieving carbon negativity by 2040. So that's something that we're really, really excited about. And we've already identified potential savings along the way there and are continuing to work on that. So when we're thinking about our units, we're not just thinking about from when we build it to when we install it. We're actually thinking 50, 100 years ahead to when it comes to end of life. What's that going to look like? So we already have the ability to mill the units up and reuse them as filler in new material, but we're also looking at opportunities for redeveloping our formulations to unlock abilities to have a truly circular production system where we're able to completely reuse and break down the components so that we can fully avoid landfill, because it's so important to us that we're doing everything we can to minimize and mitigate the impacts of new buildings on climate, because that's such a crucial thing, and because it can't be any either or. It really has to be a both and with any solution that we're looking at as a society.
So are you planning your own mighty building to live in?
Eventually, if I can ever afford to own property in California. No, actually, we have there's my mother recently passed, and so my brother, cousin, and I now share some property in Western Massachusetts that we're looking at potentially putting a unit on.
Oh, fun. So, one final question for you, because this has been fascinating. I'm just wondering if there are any other current trends or innovations in real estate development or construction that you think are really important for the future beyond what you're doing with mighty buildings.
Yeah, well, as I've spoken to, I mean, I think it's imperative that we as a society figure out how to. Well, so there's a couple areas. One is obviously the sustainability of the structures, and honestly, I'd like to go back past sustainability into resilience and regeneration, because that's really where the conversation needs to be: is how do we make housing units that are going to be resilient to the changes that are already coming down the pipeline, while also being a part of the solution in terms of regenerating the ecosystem, whether that's through carbon sequestration built into the units or other opportunities. So that's one huge area, because whether it's us or anyone else, we need to build all those units, but
Right.
we have to be thinking about the impacts on the climate crisis when we're doing so, or else we're going to be in a lot of even more trouble than we are. Additionally, looking at what does it mean to, and this is obviously a broader societal issue that comes up whenever we talk about automation and robotics, which is how do we as a society want to embrace the potential benefits of automation and technology. And so there's that. It's been great seeing some of the work happening around like universal basic income and some of these other models that began to decouple work from worth. Because I mean, Buckminster Fuller back in the 1950s was talking about how we had technology such that one person could do the job of 10,000. We should be freeing those other 9,999 to do the things that further humanity. And that's even more true today with the advances we've seen. So there's huge opportunity as a society for us to be thinking about what does it mean to embrace technology in a way that allows us to solve some of these really, really big problems, while also taking into account the potential negative consequences, because technology is neither good nor bad. It comes down to how do we as a society choose to use it. So that's another area. And then more broadly, I'm really excited about what we're seeing in terms of shifts in prefabrication and offsite construction here in the United States. You may or may not be aware about the new Advanced Building Construction Collaborative that's going to be kicked off shortly. But it's the Department of Energy, Rocky Mountain Institute, and some others are convening this amazing effort that's essentially a parallel to what was done in the 1990s for the silicon wafer chips for the semiconductor industry and microchips, where the Department of Energy basically put a lot of money into jumpstarting the industry in the face of competition from Taiwan and other places, and kept the US as a leader there. And they're looking to do the same thing for offsite construction. Because not only are we seeing some amazing buildings being built with really great modules from Poland and China, but as we've seen with the current pandemic and some of the issues in global trade, we're really running into issues with getting those units here and getting having global trade happen the way we're used to. So it's more imperative than ever that we're really identifying ways that we can unlock that capacity here in the United States to be able to generate all those homes, because that also is going to have a huge impact on sustainability of that construction in terms of the carbon associated with the transport. So I'd say those three areas are three big ones I'm really excited about, and it's conversations that are ongoing, but that we need more and more people thinking about and engaging with, I think, because there's so many good ideas out there, and the problems are so big that I don't think there's any one solution that's really going to be able to solve it for everyone.
No, I think that's true. I think we've all got to chip away in lots of different ways. Well, thank you very much for the conversation. I can hear the excitement in your voice, and I'm incredibly excited now too. I'm going to go to your website and check out that little house that's a kit of parts.
Wonderful. Well, thank you so much for the opportunity. I really enjoyed the conversation. You had some great questions, and it was a pleasure.
I'm really looking forward to see where you go. It's a big goal. Thank you.
Oh, thank you. Well, the best ones have to be audacious, or else we don't get the change we need.
That's right. That was Sam Ruben of Mighty Buildings. Sam pivoted his life and career into sustainability in a very big way. He is making all bets on the need for the world to think differently and to build differently. The melding of housing that is built quickly to fill a dire need, and housing that is built through a brand new process that reduces waste and energy, are a perfect place for Sam to be. We'll be hearing more about Sam and Mighty Buildings, I'm sure. You can find out more about this episode on the show notes page at evepicker.com, or you can find other episodes you might have missed. Or you can show your support at patreon.com/rethink real estate, where you can learn about special opportunities for my friends and followers. A special thanks to David Allardyce for his excellent editing of this podcast and original music. And thanks to you for spending your time with me today. We'll talk again soon, but for now, this is Eve Picker signing off to go make some change.